Hello my dear students, welcome you all to this lecture 2 of the chapter Kinetic Theory of Gases. In this lecture, we are going to discuss problems based on our lecture number 1. Okay, so before going into the questions, we need to go through a small concept which is called as mole concept. Okay, I know you guys are very familiar with mole concept. Even though I just want to tell you again about mole concept because there will be some students who may not be remembering those formulas. For such students, I will just discuss about the mole concept, then we will go to the problems. Okay, it is very important for doing questions. Clear? So we'll go ahead. So for telling mole concept, let me take an example. Okay. If there is a container, think there is a container and this container consists of say some balls, okay, small balls which are of identical mass. Okay, all these balls are having same mass. So if I ask you a question, what is the number of balls present in this container? Okay, so how will you do? If you are counting one by one, okay, then it will be a time taking process, right? It will be a time taking process. So what is the best method? Okay, the best method is you take a particular number of balls. Say if you take 10 balls, okay, if you take 10 balls, okay, and you take the mass of it, okay, take the mass of it. So now you know what is the mass of 10 balls, alright? Now you have to take the mass of these balls, okay, so that upon dividing the mass of balls with the mass of this 10 ball, you will understand what is the total number of balls present in the container. Am I right? Yes. So that is the best logic. Okay. Similar is the concept of mole. Instead of these 10 balls, we are considering Avogadro number, right? That is Na, which is 6.023 into 10 raised to 23. So that is the only difference between the case I have told you and the mole concept in chemistry. You have learned in chemistry, right? Yes. So what are the equations? What are the equations? What are the equations to find mole? Okay. To find the moles, mole is mu, right? Mu is equal to given mass divided by atomic mass or molecular atomic mass or molecular mass. Okay, atomic mass or molecular mass. Okay, so if you are considering an atom, suppose like helium, okay, for helium it is an atom, right? It's monoatomic. Neon is monoatomic. So if you are considering an atom, you have to consider the atomic mass. If you are considering a molecule like O2, then you have to consider the molecular mass, that is 32 for oxygen, right? So this is the way to get the number of moles. So this is the first equation. Okay, this is the first equation. Now what is the next equation? The second equation. The second equation is mu is equal to given number of particles by Avogadro number, that is Na. Okay, Avogadro number. What is mean by particles? That particles are either ions, molecules, or number of atoms. Okay, particles means that it is either the number of ions or that of molecules or that of atoms. Okay, whatever be it. So that is what we mean by particles. Okay, now I'll give you the next equation, third equation, that is number of particles is equal to given mass by atomic mass or molecular mass. Okay, given mass by, I'll put capital M, atomic mass or molecular mass, capital M. Okay, usually we put capital M for molecular mass. Okay, but now you just consider either it is atomic mass or molecular mass. You have to write it, but since I am somewhat lazy, I am just putting M. Okay, multiplied with Avogadro number, that is Na. Okay, so these three equations are very important. And also I'll give you another point, that is not, you have to note, for gas at STP, you know what is STP, right? Standard temperature and pressure. Okay, that is pressure is 1 atm and temperature is 0 degrees Celsius. That is STP condition, right? The volume corresponding to 1 mole is 22.4 liter. Okay, 22.4 liter. So these are the things that you have to remember regarding the mole concept. Okay, so now let's move on to the first question for today. That is, here it is, a vessel contains two non-reacting gases. Okay, that is neon, which is monoatomic, and oxygen, which is diatomic. The ratio of their partial pressure is 3:2. You have to estimate the ratio of, the first one is number of molecule, the second one is mass density of neon and oxygen in the vessel. So that's the question. So there is a vessel, right? There is a vessel. In this vessel, there is two types of gases. One is neon and another one is oxygen. Okay. Now, the ratio of their partial pressure, that is partial pressure of neon by partial pressure of O2 is given as 3:2. Okay, it is given as 3:2. Also they have given that the atomic number of neon, okay, the atomic number of neon is given as 20.2 and the molecular mass of O2 is given as 32. Okay, so these are the given data. Now we have to estimate, the first one is number of molecules. Okay, number of molecules. We know that the number of molecules is represented using capital letter N, isn't it? So the number of molecules of neon by number of molecules of O2. This is what you have to find. Now during our discussion in lecture number 1 or during the previous discussion of mole concept, we know that the number of moles mu is given by number of molecules divided by Avogadro number, isn't it? So from here we can write that N is equal to mu times Na. Do you remember this? Do you remember this? Yes. So we can write number of molecules of neon by number of molecules of oxygen is equal to number of moles of neon by number of moles of O2 multiplied by Na. Here also there will be Na, isn't it? So what happens? This Na in the numerator and Na in the denominator get cancelled. So basically the answer will be mu Ne by mu O2. Right? So what we need is the ratio of their number of moles. How to get the ratio of their number of moles? We can look at the given data. The given data is basically partial pressure. For partial pressure, we learned an equation during the discussion of Dalton's law of partial pressure. Do you remember? The partial pressure of a gas, okay, is mu RT by V from ideal gas equation, right? So we can tell that upon dividing this quantity, that is mu Ne RT by V divided by mu Ne RT by V, sorry, this is not mu Ne, it is mu O2, right? Mu O2, okay. Mu O2 RT by V. Here temperature, volume remains the same, okay, because we are considering a single vessel. Inside that the volume is fixed and the temperature is also fixed. Okay, so we can cancel the common term RTV, right? And this ratio is equal to partial pressure of Ne by partial pressure of O2. So which is already given 3 by 2, isn't it? Which is already given as 3 by 2. So what you have to understand is mu Ne by mu O2 is equal to the ratio of their partial pressure, which is equal to 3 by 2. Therefore, what will be your answer? Your final answer you can write here 3 by 2. Clear? So that is the required answer, 3 by 2. I hope you understood this, right? Now what about the next question? The next question is the mass density of neon and oxygen in the vessel. That's the next question. How to do that? Now what is mean by mass density? The mass density is given by density is equal to mass by volume, right? Mass by volume. So we need is density of neon by density of O2 will be equal to the mass of neon by volume divided by mass of O2 divided by volume, so that these two volume will get cancelled and the remaining is mass of Ne by mass of O2. In the discussion of mole concept, we have learned a formula, that is number of molecule is equal to given mass by molecular mass into the Avogadro number. Do you remember this? So from here we can write the small m is equal to capital N, that is number of molecules, multiplied by molecular mass divided by the Avogadro number Na. Okay. So now let's substitute it here. Okay. Which is number of molecules of Ne multiplied by the atomic mass. Since neon is an atom, not diatomic, it is not molecule, it exists as an atom, right? So the atomic mass of Ne by Na whole divided by that of oxygen, number of molecules of oxygen into molecular mass of O2 by Na, isn't it? So from here the common terms, sorry, this is not a common term, right? It's not a common term. The common terms can be cancelled, which is Na and Na. Okay, what about the remaining things? We get the density of Ne by density of O2 is equal to number of molecules of Ne multiplied with the atomic mass of Ne divided by number of molecules of O2 into molecular mass of O2, which is equal to, what was the previous answer? The previous answer, that is number of molecules of neon to number of molecules of oxygen, is 3/2, and their atomic mass and molecular mass is already given 20.2 and 32, right? So here you can write it is 3/2 into 20.2 divided by 32. So what is the answer? I am using calculator. Okay, you have to do it without calculator. So your answer is 0.946. Okay, 0.946. That is the required answer. I hope you understand this question. Alright. So it is very simple. If you know the mole concept and if you have watched the lecture 1, then this could be very simple. Okay, let's move on to the next question. The next question is, a gas at 27 degrees Celsius in a cylinder has a volume of 4 liter and pressure 100 Newton per meter square. Okay, gas is first compressed at constant temperature so that the pressure is 150 Newton per meter square. Calculate the change in volume. So that's the basic question. Okay, so we had a container. So what is the given data? The volume is given. Let the initial volume be V1, which is equal to 4 liter. The temperature is given. Okay, the temperature is given as 27 degrees Celsius. Okay, if you need, you can convert it into Kelvin. So it is 27 plus 273, which is equal to 300 Kelvin. 300 Kelvin. Okay. Now, the pressure P1 is given as 100 Newton per meter square. Now what happens? You are compressing the gas at constant temperature. Okay, so if you either convert or does not convert it into Kelvin, it doesn't matter, because in this process your temperature is remaining as constant. The temperature will not change. Temperature will not change. Okay. Now, so you are increasing the pressure. You are increasing the pressure. Your pressure becomes 150 Newton per meter square. You want to calculate the change in the volume. What is mean by change? Change always means final minus initial. Change in velocity. Final velocity minus initial velocity. Change in momentum. Final momentum minus initial momentum. Change in volume. Final volume minus initial volume. Okay. So, change in the volume means V2 minus V1. For finding this, first of all you need to get what is V2. You need to get what is V2. Okay. So how to do it? Since in this process the temperature is remaining as constant and you are increasing the pressure, so which basically it is Boyle's law, right? Boyle's law. That is, pressure is inversely proportional to volume. Or you have learned Boyle's law as PV is equal to a constant. PV is equal to a constant. There I have given you a formula. P1 V1 is equal to P2 times V2, right? From here we can write the equation for V2 as P1 V1 by P2. So using this, let's calculate the second volume. P1 is 100, your V1 is 4 by P2 is 150. So what will be your answer? Let's calculate the answer, okay? So your answer is 8 by 3 liters. 8 by 3 liter. Now what is the change in volume? The change in volume can be written as V2 minus V1. Your V2 is 8 by 3 and your V1 is 4, right? So upon subtracting this, you get 8 minus 12 by 3, which is equal to minus 4 by 3 liters. Clear? Minus 4 by 3 liters. 4 by 3 means 1.33. Alright? Why there is a negative sign? It is because you are increasing the pressure so that the volume should reduce. Okay. So your final volume is less than the initial volume. That is why the value is negative. Okay. That's all. So the answer numerically, just considering the value, it will be 1.33 liters. That's all. Okay. Now let's move on to the next question. Here is the next question. From a certain apparatus, the diffusion rate of hydrogen has an average value of 28.7 centimeter cube per second. Okay. The diffusion of another gas under the same condition is measured to have an average rate of 7.2 centimeter cube per second. You are asked to identify the gas. So it belongs to Graham's law of diffusion. Okay, Graham's law of diffusion. Do you remember that? So let's write the given data. The rate of diffusion of hydrogen which exists as H2, right, is equal to 28.7 centimeter cube per second. Now there is another gas. We don't know which is the gas, so let's put G here. Okay, Rg is 7.2 centimeter cube per second. Okay. Now you are asked to identify the gas. During the discussion of Graham's law of diffusion, I have given you a formula. R1 by R2 is equal to square root of M2 by M1. Do you remember? So using this, let's consider this is first and this is second. We can write RH2 by Rg is equal to the square root of MH2 by square root of Mg by MH2, isn't it? Yes, they are inversely proportional. Okay, so how to do it? This RH2, that is 28.7 by Rg, which is 7.2, is equal to square root of Mg, the molecular mass of the gas is not given, MH2. For hydrogen, for the atomic mass unit, AMU is 1U, right? Unified mass, 1U. So for H2 it will be 2. So you square it, 28.7 by 7.2 the whole square is equal to Mg by 2. So that your Mg is equal to 2 times that of 28.7 by 7.2 the square. Let's calculate the answer. Okay. Your answer is 31.778. Okay. So your mg is 31.778, which is approximately 32, isn't it? It's approximately 32. Which is the gas? Yes, oxygen, right? So gas is O2. For a single atom of oxygen, it is 16. For O2, it is 32. So it will be oxygen. Okay. So that's the required answer. Now let's see what is the next question. So the question is, an air bubble of volume 1 centimeter cube rises from the bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. To what volume does it grow when it reaches the surface, which is at a temperature of 35 degrees Celsius? Okay. So according to this question, there is a lake. Okay, there is a lake. And in this lake, at a bottom 40 meter, there is an air bubble. So this is the air bubble, which is at a 40 meter depth. Now let's write the given data. As per the given data, the volume of this air bubble was 1 centimeter cube. The temperature T1 is 12 degrees Celsius. Okay. Now this air bubble is going to the top. Okay. It is going to the top. Suppose this is the air bubble which is at the top. Then the temperature of this air bubble at the top is 35 degrees Celsius, and the volume is the question, right? What about the volume? V2. So that's the question. So basically, do you think this is based on Charles' law? Because we have temperature, they are asking about volume. So do you think it is Charles' law? It is not Charles' law. You have to be careful while dealing with problems. You know that according to fluid, you have learned fluid mechanics, where if you move to a depth in the fluid, then the pressure will increase by an amount rho GH, isn't it? So the pressure is not constant. The pressure at the bottom and pressure at the top is different. Hence it is not based on Charles' law. Okay. So what about the pressure at the top? At the top part, since it is the surface, it will be the atmospheric pressure 1 atm, which is equal to 1.01 into 10 raised to 5 Pascal. Do you agree? Now what about the pressure at the bottom? The pressure at the bottom is P1, which we have to calculate. Okay. So your P1 will be equal to P2 plus rho GH, because as we are moving down, the pressure will increase by an amount rho GH. So that it is 1.01 into 10 raised to 5 plus rho is the density of water, which is 1000. G is acceleration due to gravity, which is 9.8. H is the depth, which is 40 meter given in the question. So you get the answer as, just calculate it, okay? So your answer will be 493,000 Pascal. So this is the pressure. Okay. Now which formula we are going to use to get the volume V2? You know that from Boyle's law, the pressure is inversely proportional to volume, right? Then from Gay-Lussac's law, we know the pressure is directly proportional to temperature. So upon combining these two equations, can we write the pressure is proportional to T by V? Can we write like that? Yes. So PV by T should remains a constant, isn't it? Isn't it? Or you can write this from the ideal gas equation also. Both are okay. Okay. Then we can tell that the P1, V1, T1 at the bottom should be equal to P2, V2, T2 at the top. Okay. We can write P2, V2, T2 is equal to P1, V1 by T1. Isn't it? So how to get V2 from this equation? Your V2 is going to be P1 V1 T2 by P2 T1, isn't it? So let's substitute. What about P1? What is P1? What is P1? P1 is 493000. Okay. P1 is 493000. What about V1? What about V1? Your V1 is 1 centimeter cube and your T1 is 12 degrees Celsius. Okay. So let's go ahead. This is 1 centimeter cube, right? I'm not writing unit, okay? We don't want the unit. Just write the value, okay? 1. Then we need T2. Okay, what is T2? T2 is 35 degrees Celsius, okay? So we can write this 35 plus 273 because we need that in Kelvin, okay? Divided by P2, which is the pressure at the surface, right? Which is 1.01 into 10 raised to 5 multiplied by T1. I guess T1 was 12 degrees Celsius, yes. So that will be 12 plus 273. So upon solving this, let's calculate. Okay, you just pause the video, do it yourself and check whether you get the same answer. Okay, don't just copy this. So your answer is 5.275 centimeter cube. Do you also get the same answer? So let's see the next question. This is the last and final question of this lecture. Okay, so let's see this. Estimate the total number of air molecules inclusive of oxygen, nitrogen, water vapor and other constituents. We know that air have many constituents, right? So in a room of capacity means volume, 25 meter cube at a temperature 27 degrees Celsius and 1 atm pressure. So basically the given data is volume, which is 25 meter cube, the temperature, which is 27 degrees Celsius, or which is equal to D7 plus 273 gives 300 Kelvin. The pressure is given to be 1 atm and you are asked to find the number of air molecules, which is n. You are asked to find the number of air molecules, which is n. Do you remember the first formula we learned during the starting of this chapter? What was it? It is PV is equal to N kB T, right? So from here the number of molecules can be written as PV by kBT. Okay, so let's substitute. What is P? P is 1 atm. We have to convert it into SI, right? So it is 1.01 into 10 raised to 5. Okay, 1.01 into 10 raised to 5 into volume, that is 25 by kb, which is 1.38 into 10 raised to minus 23. I hope you remember that value. And T is your temperature, which is 300, right? 300. Okay. So do it yourself and put in the comment box what is the answer of this question. Okay. So see you all in the next lecture. Bye bye.